Okay. Now we are on video tutorial 5, which is still on solving trigonometric equations. So this time we will be solving tangent theta, the square of tangent theta, plus 3 times secant theta, plus 3 is equal to 0 for the values of theta from 0 to 2 pi. So in this equation, you will notice that we have two different trigonometric ratios, tangent and secant. So to solve this equation, our goal first is to make it a single trigonometric ratio, which means it's either all tangent or all secant or any other trigonometric ratio as long as there's only one trigonometric ratio in the equation. Currently, we have two. So how do we do that? We need to remember our trigonometric identities. So from pure mathematics 1, in the first term, we discussed about some identities, some basic identities. If you will remember, tangent squared theta is also the same with sine squared theta over cosine squared theta. And then now, secant theta, we know that secant theta is 1 over cosine theta. This is what we are currently studying, the reciprocal ratios. So looking at these two, which identity can we use to achieve our goal, which is to make the entire equation have one ratio only? None so far. Because if we use this, then we will have sine, cosine, and secant. If we use this, then we will have tangent and cosine. If we use both, we will have sine and cosine. So it's still not a single ratio. Therefore, we need to know another identity. Okay. This is the identity that we also studied from Pure Maths 1. If you remember, sine squared theta plus cosine squared theta is equal to 1. Now, why did I bring this up? Because there are two new trigonometric identities that will be derived from this. And one of them is what will help us to solve this equation. Okay. We need to make everything, we can make everything into secant. How's that? Okay. So from this equation, let's divide everything by cosine squared theta. Everything here. So this divided by cosine squared theta. This also divided by cosine squared theta. And this also divided by cosine squared theta. Why did I do this? Because tangent squared theta can be written as this. So this is tangent squared theta. Tangent squared theta. Plus, so this is just 1. Equals, and this one, can be obtained from here. So that means 1 over cosine squared theta is secant squared theta. So we have created, or we have found, a new identity where tangent and secant are connected. And that's what we have here in our equation, tangent and secant. So now we have a way to make this into a single ratio. So that means I can write tangent squared theta in terms of secant because of this equation. So instead of tangent squared theta, I can now write it as secant squared theta minus 1. This one. So it will now be secant. Tangent squared theta now is this. Where did I get this from? From this identity. Then, plus 3 times secant theta plus 3 equals to 0. By the way, you can just memorize this identity. Or you can derive it like what I did just now. Okay. Or you can just simply memorize it. So now you see that from two different ratios, everything now is secant. So all we have to do is simplify the equation. That means this is going to be quadratic. So I will have secant squared theta plus 3 secant theta plus 2 equals to 0. Okay, quadratic. So we can use substitution. Let's use x. Let x be secant theta. And that will make this equation into x squared plus 3x plus 2 equals to 0. Okay, we can solve for the values of x. I will use factorization. So the factors are x plus 2 and x plus 1. So I have two values for x, negative 2 and negative 1. But I am not solving for x, I'm solving for theta. X is secant theta. So that means secant theta has two values, negative 2 and negative 1. And from here, you will know what will happen. Get the basic angle and then get the values for theta. And no need to change the domain because the ratio secant is using the angle theta, which is what we also want to get. So we don't need to adjust or change the domain. So from here, you just continue finding the values of theta.